So today we're going to look at, we've got information here, and they're going to ask us to put this information into matrix form. Why do we do this is because like a lot of computer coding and things like that, it has to be put into like a number system so that like computers can handle it, yeah? So, and you can, you know, solve a lot of things. But so that's why we're going to do it. So here, you just follow what they say with the way to construct it. So it says construct a matrix to display the information and what is the order. So all you have to do is simply just write it out with those square brackets in it. So if we do that, so I'm just copying out those numbers up there and into a matrix form. So what do the rows represent when I do this? They represent the houses, don't they? And what do the columns represent? Just the, you know, the residents, TVs and computers, doesn't it? Yeah? So, what's the order of this one? What's this one? Good. The order is 3 rows and 3 columns, so a 3 by 3. Okay, so now it says, alright, so in this question B, it says construct a row matrix to display the numerical info in the table relating to house B. So house B is up here. So and because it's a row, we only have one row. So that means I have to put that, all the things that happen in like that. So what's the order of a row matrix, this row matrix?
1 by 3.
Yeah, it's a 1 by 3. A row matrix will always have a 1 at the front because there's only one row in a row matrix. And then they ask you to construct a column matrix of the info for computers. So you can see column here. So we pop that into a column matrix. So we just have to do that. What's the order of a column matrix? We've got to do rows first. So 3 by 1. So a column matrix will always have the second number being a 1. Now, what does the sum of the elements, if like we added all these up, so remember sum means add. So if you add all these up, it equals 4. What does that tell me about the data? Like there's 4 computers in all the houses, yeah? So you might just say there's a total of 4 computers in this data, yeah? 4 computers in this data, okay? So they're just, you need to be able to interpret. So if we gave a matrix, you know what it's sort of telling you, and that if you added all them up, it'd tell you all the computers. So it's pretty easy. Okay, so as we said, we can use, we can get digital data and we can, you know, represent it in a matrix. Here they want us, this is a credit card number, and they want us to put it into a matrix, but they want to list the digits in pairs and one under the other and ignore spaces. So all that means here, because this is actually how some of the card readers work when you swipe a card. So the pair is you go 3, 5. So see how I've gone that one? And then the next one would be 4, 2 underneath. What's the next one going to be? 8, 2, 7, 9, 0, 0, 2, 0, 3, 0, and 6, 9. What's the order of this one? What's the order of this matrix? 2 by 8. Now, if there was 16 numbers, that means there's 16 elements, isn't there? And 2 by 8 is 16. Okay, so sometimes we have a scenario where we have a diagram, and these diagrams down here are called network diagrams. Network diagrams are when you have like the points, and you have, so you might want to say a network diagram is where you have the points and lines joining them. Yeah? So we have joining points. Okay, so what we like to do is sometimes we like to change the diagram into a matrix, so we tell to display the information. So here we're going to say if there's a line between the 2 points, we're going to put a 1. If there's no line between them, we're going to put a 0. This is when we create our matrix. So when we create a matrix of a network diagram, how many points you are is how many rows and how many columns you're going to have. So because there's 3 points here, this one's going to be a 3 by 3. So what I'm going to have is it's like 1, 2, 3 and 1, 2, 3. Now what I'm going to do is I'm going to say I'm at 1, and I'm going to say how many lines go from 1 back to 1. Now, there's none that just loop around. When you have a line that goes back to it, so say that was town 1, it'd look like that, where it doesn't go anywhere else but back. So are there any in this one? No. Now, is there a line between 1 and 2? Yeah, so we'll put a 1. Is there a line between 1 and 3? Directly? No. So we'll put a 0. Is there a direct line between 2 and 1? Yes. Is there a 2 back to 2 only? It'd be a loop. No. And what about between 2 and 3? Yeah. What about 3 and 1? A direct line? No. 3 and 2? Yes. And 3 and 3? No. There's no loop, is there? Okay, so if I had the next one, I've got 4 points, so what would the order of the matrix be for this one? Good, it's going to be a 4 by 4. So what we're going to see is 1, 2, 3, 4, and then across the top 1, 2, 3, 4. Okay, is there a line that's looping back to 1 to 1? No. Is there a line between 1 and 2? Yes. A line directly between 1 and 3? No. A line between 1 and 4? No. Directly. Oh yeah, there is. Sorry. Tell you a lie. Yep, good work. So it's a 1. What about 2 and 1? Yes. 2 and 2? No. 3 and 2? Yeah. And 2 and 4? No. 3 and 1? No. 3 and 2? Yes. 3 and 3? No. 3 and 4? 1. Okay, the last one. 4 and 1? Yes. 4 and 2? No. 4 and 3? Yes. And no. Alright, so I'm going to pause for a sec. You guys go do the next one and I'll... Okay, so this last one, I've put a 1 by 4, yeah? So here, when we say here, when we're between 1 and 3, there's a path. Can you see? There it is. Yeah? And say, if we looked at 4, point 4, point has a path, 4 has a path to 1, 2, and 3. So can you see there it is? The 1, 1, 1, 1. Okay? So, did everyone get that answer? So, represent the diagram by 3 by 3. So they're telling me how to set my matrix up. So they want a 3 by 3. So it'd be 1, 2, 3, 1, 2, 3. And it says where the element represent the number of rows between each of the pairs of towns. So between town 1, is there a road that just goes out of town 1 and comes back to town 1? No, there's no road. What about between town 1 and town 2? Is there a direct path or road? No. What about town 1 and 3? Yes. Okay. 2 and 1? No. 2 and 2, there's no loopy one, is there? No. Now, how many paths are there, or roads, is there between 3 and 2, or 2 and 3? There's 3, isn't there? So here, there's 1 between that, there's 3, and there's 0. So you just got to be careful, read the question of what they're asking. So this one we had to count up how many roads there were. In the next part, it said, so we don't have a diagram, but we've got a matrix, and it shows us, well, let's draw a diagram because they haven't drawn it. So we've got friends, we've got 5 girls that are friends. Okay, if I go across here, friend 1, she is only friends with 2. So I might just connect them up like that. What about girl 2? She's friends with 1, so I've got that there. And who else is she friends with? 3. Okay. And what about 3? 3 is friends with 2, we've got that. And he's also friends with 4 and 5. Okay, what about friend 4? Girl 4 is friends with 3, we've got that. And she's also friends with 5. So I'll draw it there. And what about 5 is friends with 3 and 4, and they're already there. So that would be the diagram, and here is the matrix. So this is the matrix, and this is what we call the network. Alright, so we've done that. Now they're asking me, they're calling this matrix F. So they probably like that, yeah? So when they ask you what's F3 for, so that will be, we've got to go to row 3, column 4, and it's a 1, isn't it? And what does that tell us? What if there's a 1 there? 3 means girl, what is it? 3 and 4 are friends. Isn't that true? Yeah. And if we go to row 2, column 5, there's a 0. What does that tell us? Girl 2 and 5 are not friends. Okay, so looking at our stuff, the sum of the elements in row 3. So if we add all them up, that equals 3. And what does that tell us? Good. Girl 3 has 3 friends. Okay. And what about the last bit? Which girl has the least amount of friends? Who's got the lowest? 1. Girl 1. And who's got the most? Girl 3? Yeah. Okay. All right.